Hello, everybody. Mr. Klein here, rocking and rolling. And now it's time for us to look at how we can use Google Sheets to analyze a data set and determine whether it follows the normal distribution. It's basically the same idea of what we were doing earlier in class, except for now using Sheets. All right, so let's see what our data set is. These are the weights at birth of babies that were born in the month of November at a local hospital. And these right here are the not so clever names given to them by their millennial parents. Here we go. We got 7 steps. First step is to determine the mean and the standard deviation. This is the same thing that we were doing in Unit 1. So you're going to go average of, let's see, the births are in column B. So we're going to go from B5 down to B204. So the mean weight in this distribution is 7.1 pounds. And then the standard deviation, I'm just going to type in, I know that we're starting at B5 and ending at B204. And that gives us this. So our standard deviation is about 0.9 of a pound, pretty close. And then N means our sample size. You're going to use the count formula to calculate that. So we'll do the count from B5 to B204. So there were 200 babies born during that month. Okay. So there's the information we need for 1. Next thing I want you to do is look at the shape of the data by actually graphing it. So I want you to provide a histogram of these data, and you're going to use Stapplet. So type stapplet.com into your search engine, or just into the bar up here. And then you're going to go to one quantitative variable, a single group. I typed in the name of the variable right here, weight at birth in pounds. And then I copied all 200 of the weights here. Let's begin the analysis. So we get a distribution. It looks kind of normalish. I think that the dot plots are a little hard to read on Stapplet, so I am going to ask you to make a histogram. Now, when you make these histograms, sometimes they don't show as much of the shape as I would like. So I just want to remind you guys that up here, you can adjust the width. So let's use as a boundary value, that means like one of the numbers that has to be included, something like 5, a whole number, right? And then for the interval width, it looks like it's at 0.5. First note that if I go up to something like 1, you really don't get a whole lot of shape at all. So let's go down to something like, I don't know, 0.2. Okay. 0.2, we can get like a lot of the shape. Notice that if you go really small, if you go something like 0.05, you're going to get too much shape. You get like, you don't want that much variation. Something like 0.2 is probably good. 0.5 wouldn't be the end of the world. All right, so there's our distribution. It looks kind of normalish. Not 100% sure, but I'm feeling pretty good about this one. I'm going to paste that in right here and do a little shrink-a-dink. Okay. Next thing, determine each of the intervals. And what I mean is determine the boundaries on the intervals. So we want the interval that goes from 1 standard deviation below to 1 above, and then from 2 below to 2 above, and then from 3 below to 3 above. So here's how we're going to find this. This first one is 1 standard deviation below and above. So for the lower, I'm going to say take the mean value and subtract 1 standard deviation from it. And then for the above, I'm going to say take the mean value and add 1 standard deviation to it, just like we did by hand in today's lesson. Right. Now for the next one, so this right here is going to be like your 68% interval, right? Here's your 95% interval. So what we need to do for this one is take the mean and then go 2 standard deviations below. And then the mean plus 2 standard deviations above. Finally, we're going to do the mean and 3 standard deviations below the mean and 3 standard deviations above. Okay. So there are going to be our boundaries for 1, 2, and 3 standard deviations. Let's get the counts that go in each one of these. This is what I find to be kind of the trickiest part. Our first interval goes from 6.21 to 7.99. So I need to come over here and find all of the values that fall in that interval. It would be really hard the way the data is organized, but if we sort it ascending, that'll make everything a lot easier. So make sure that you highlight both column A and column B, because we wouldn't want to lose all the clever names that these girls have while we are sorting the data. Come on up here and tell it to sort column B from A to Z, which will be from least to greatest. Okay, so there's our smallest baby, Emma, and there's our largest baby, Ella. And we want the interval that goes from 6.21 to 7.99. So let's see, 6.21 would be in between this number and this number. So this number is in the interval. I'm going to highlight that in yellow. And then so is everything below until, okay, so that would be the first number that's in. Now, 7.99 is the upper bound of the interval. So I'm going to go down to where 7.99 would be. That's right here. If it is right on the bubble, include it in the interval. So that's in the interval, and so is everything in between. So what I've done here in yellow is I have highlighted all of the babies whose weights fall in this interval between 6.21 pounds and 7.99 pounds. I need to know how many of them there are. So now I'm going to count the yellow babies. And that gives me 138. Cool. All right, let's get the counts for the rest of them. So now when we go to 2 standard deviations, this is going to add more values. So we can now go all the way down to 5.33, which means it would include this value, all of these, till, let's see. Oh, there's a 5.33. So Olivia here would be included in the interval, but Amelia here would be too small for the interval. I'm going to highlight those in orange. And then we're going to go all the way up to 8.87. So that would include all of these. 8.8 is right here, 8.86. So Ava is included in this interval. Olivia would be too big, so I'm going to highlight those in orange. Keep in mind that all of these yellow babies are also in the orange interval, right? So when I do the count here, I'm going to go all the way from this number to this number. So 190 of our babies are within 2 standard deviations. Finally, let's go to 3 standard deviations. Usually this is just about everybody. Let's see if that's the case. So 4.44, yeah, all of these would fall into that red group. And then what was our upper bound? Our upper bound was 9.76. So that would be everybody but Ella. She's a big girl. All right. So basically we're including everyone but Ella in the red group. And so I'm not even going to bother counting. I know that there's 200 values, so that would be 199 are going to go here. The next thing that you want to do is you want to divide these by the count. So 137 divided by the count, 138 gives us 69%. If I just copy that formula, it'll actually paste here and here. So our distribution has 69% within 1 standard deviation, 95% within 2 standard deviations, and 99.5 within 3 standard deviations. The distribution that we are comparing with is 68, 95, 99.7. Oh, by the way, no, never mind. Let's keep going. So close, 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 conclusion. Yes, these data are normally distributed. Actually, let's do it this way. Yes, the weights of female babies at birth are normally, if I can spell, distributed because these data follow the 68, 95, 99.7 rule. Let's wrap that so you can see it. And that's the game, folks. That's how you use Google Sheets to determine whether a data set follows the normal distribution or not.